my name is Kirti. In the last lecture, I had explained you what is quantum tunneling, and in this lecture, we shall solve two numerical problems based on the topic. So let us first take 2 minutes to recapitulate what we had learned in the previous class, and then we will see what kind of problems can be asked from this topic. Okay. So in the last class, we saw that if a particle encounters a potential energy barrier, then there are two things that can happen. If the particle is classical particle, it will definitely be bounced back by this potential energy barrier. But if this particle is a quantum mechanical particle or a quantum particle, then there is a chance that this particle tunnels through this barrier and go to the other side of the barrier. This happens because a quantum particle has both wave nature and particle nature. So these are the things that we had seen in the last class. So here the energy of the particle is given by the symbol E, the height of the potential energy barrier is given by V, and the width of the potential energy barrier is given by L. So what kind of questions can be asked from this tunneling topic? So they might ask you to find the probability that a quantum particle tunnels through this barrier and appear on this side of the barrier. So they might ask you what is the tunneling probability of a particle. Tunneling probability. By the way, this tunneling probability is also called transmission coefficient. Transmission coefficient. Actually, transmission coefficient is the parameter by which you can measure the tunneling probability of any particle through a potential energy barrier of height V or potential V and width L. Okay. Sometimes they can give you the tunneling probability of the particle and they can ask you to find the energy of the particle. Okay. Or they can give you everything except the height of potential barrier, and they can ask you to find the height of potential energy barrier. Okay. So these kind of questions can be asked from this tunneling quantum tunneling topic, and we will see how to find the tunneling probability of a particle which has energy E through a potential energy barrier of potential V and width L. Okay. So this tunneling probability is given by a formula T is equal to e power minus 2 gamma L. Okay. So here L is the width of the potential energy barrier, and gamma, which is called decay factor, is given by root 2m V minus E over H cross. Okay. Here m is the mass of the particle, V is the height of potential energy barrier, E is the energy of the particle, H cross is the reduced Planck's constant. So H cross is given by H over 2 pi. So this is reduced Planck's constant. So when you are given all of these values, then you can easily find quantum tunneling using this formula, right? So it is easy to write formulae and then solve the problem, but the most important thing to know is how is this being derived. Okay, so you must look into the derivation of tunneling probability. If possible, we will also do it on our channel, but it will take about 1 to 1.5 hours to derive this tunneling probability. Okay, the derivation is simple, but it is long. So it might require 1 and 1.5 hours. So we will not do in this class. We will just solve the numerical problems using this formula, and in some other class we will see how to derive tunneling probability. So now let us solve the questions. I'll write the formula on this side. Let us solve this first question, which says that an electron with energy 5 electron volt approaches a potential energy barrier of height V is equal to 10 electron volt. So you have the value of V and E. E is 5 electron volt and V is 10 electron volt. And and the thickness is 1 nanometer. So the thickness is given by L, right? So L is given as 1 nanometer. Find the tunneling probability of the electron through the barrier. Now what you have to find is the value of T, which is given by e power minus, this should be minus 2 gamma L. Okay. You are also given the mass of the electron. So you have all the values. You can find the value of gamma and plug this gamma in this equation to find the value of T, right? But here the most important thing you need to note is that you have to convert all these units into 5, right? Yeah. You have to convert all these values into standard SI units. Okay. So the standard unit for energy is joule, right? You have to convert electron volt into joule. So I give you the conversion here. So 1 electron volt is equal to 1.602 into 10 power minus 19 joules. Okay. So now we will find the value of gamma. So gamma is 2mV minus E. So first let us find what is V minus E. So V is 10 electron volt and E is 5 electron volt. So the result will be 5 electron volt. Now I have to convert this 5 electron volt V minus E into joules. So 1 electron volt is 1.602 into 10 power minus 19 joules. So 5 electron volts will be 5 into 1.602 into 10 power minus 19 joule. So this value I have solved and it comes out to be where is it? Yeah, it comes out to be 8.01 into 10 power minus 19 joules. Now we have the value of V minus E. Now we'll see what is 2m into V minus E. So 2m into V minus E. So this is what it is, right? 2m into V minus E. So it is, you have to multiply 2 into 9.31 into 10 power minus 31 kg. And what is the value of V minus E? 8.01 into 10 power minus 19 joules. So minus 31, 10 power minus 31 into 10 power minus 19 will be 10 power minus 31 plus minus 19. That would be 10 power minus 50. So I'll remove this and put it as 10 power minus 50. Okay. So we have 2 into 9.31 into 8.01 into 10 power minus 15. So this value turns out to be 149.1462 into 10 power minus 50. So I can write it as 1.491462 into 10 power minus 48, right? I have taken this decimal to the left by 2 units, okay, by 100 units. So I am multiplying it with 100, that will be 10 square. So it would become minus 50 plus 2 is minus 48. Now we have to take the root of this value. So its root comes out to be somewhere around 1.22 into 10 power minus 24. Okay. Now you will understand why I had converted this minus 50 to minus 48. This is because in the denominator we have reduced Planck's constant. And if you see reduced Planck's constant, h is equal to h cross over 2 pi. Sorry, h cross is h over 2 pi. So the value of h is 6.023 into 10 power 23 joule second by 2 into 3.14. So its value comes out to be 1.055 into 10 power minus 34 joule second. So in the denominator we have minus 34 and in the numerator we have minus 24. So it would become easy to solve the problem. Okay. So it would be 1.055. In the denominator we have h cross and the value of h cross is 1.055 into 10 power minus 34. So this comes out to be 1.157 into 10 over 10. So you know that minus 10 power minus 24 plus 34 would give you 10 power 10. So this is our value for gamma. And we have to just plug in this gamma into t is equal to e power minus 2 gamma n. So when you do this, I'll write it here. T is equal to e power minus 2 into the value of gamma is 1.157 into 10 power 10. And what is L here? L is 1 nanometer. So we have to convert nanometer into meters because we are going to use SI units, right? So 1 nanometer would be 1 into 10 power minus 9 meters. Okay. Not 19, it would be 9. So here I would write 1 into 10 power minus 9 meters. So this would give me 10 power 10 into 10 power minus 9 would be 10 power 10 minus 9, which would be 10 power 1. So it is going to be 10. Okay. It is just going to be 10. So this 2 gamma L will not have units because the unit of length is meter, right? So the unit of length here is meter. Then the unit of gamma would be 1 by meter. So gamma would be meter inverse. So this would cancel each other and you will have no units for gamma. So how would I say that unit of gamma would be meter inverse? We'll see that in a short while. We'll plug in all the units for these values and try to find the unit of gamma. Just give me 2 minutes, okay? First we'll solve this. So T here would be, when you solve this thing, the number you get is 0.89 into 10 power minus 10. So that would be approximately 1. You can take 0.89 as 0.9 or 1, right? Into 10 power minus 10. So the tunneling probability of this electron, which has a mass of 9.11 into 10 power minus 31 kg, is so less. It is on the order of 10 power minus 10. Okay. So this is how we solve this question using these formula of tunneling probability. You just have to find the value of gamma and plug this into this equation. Okay. So now we will solve the second problem. Before we solve the second problem, we'll see why the unit of gamma is 1 by meter, okay, or meter inverse, So I had told you this tunneling probability is just a number, so it will not have any unit, and for that e power minus 2 gamma L should be unitless, right? We already know that 2 is a number and L has a unit of meters because it is the width of the potential energy barrier. It is given in the units of meter. Then gamma should have the unit of meter inverse so that both the units get cancelled and this will be just a number. Okay. If this is a number, then tunneling probability will obviously be a number. Okay. So we will see how the unit of gamma would be meter inverse. So gamma is equal to 2 into m. So we will omit this 2 because it has nothing to do with units. So we will take the unit of mass as kg and V is the energy and E is also the energy. The unit of energy is joules, right? And we know that joule is kg meter square second power minus 2. Okay. So this is the basic unit of joule, kg into meter square second power minus 2. So I'll replace this joule with kg meter square second power minus 2. And in the denominator you have h cross, which is h over 2 pi So 2 pi is just a number, but the unit of h is joule into second. So in the denominator we will write joule into second, and we know that joule is kg meter square second power minus 2. So I will replace this joule with kg meter square second power minus 2. So second into second power minus 2 will be second power minus 1. Okay. And here under the root kg into kg becomes kg square. So this would be kg square meter square into second power minus 2. When I take the square root of it, it would be kg. So this square and root will get cancelled, and this would be kg meter second power minus 1. So this cancelling is not the right thing to do, but when you take the square root of these values, you will get kg meter, and in these units you will get kg meter and second power minus 1. And in the denominator you have kg meter square second power minus 1. I'll cancel kg, I'll cancel second inverse. Now you have meter into, okay, I'll cancel 1 meter here. So you have 1 over meter, which is meter inverse. Now you have to agree to me that the unit of this value parameter gamma is meter inverse. Okay. Now let us solve this second question. So the question is, the probability of an electron penetrating potential barrier of 10 electron volt is equal to 0.8%. So here you are given the height of potential energy barrier, that is V. You are also given the probability, tunneling probability, the value of T, that is 0.8%. So V is 10 electron volts and T is 0.8%. So what does this, the value of T is equal to 0.8% mean? It means that if you are, if 100 electrons encounter this potential energy barrier, then there is a chance that only 0.8 electron will pass through the potential energy barrier. Or you can put it this way, if 1000 electrons encounter this potential energy barrier, then there is a chance that only 8 electrons will pass through the potential energy barrier. Okay. So T is 0.8% and width is given 0.6 nanometers, which would be 0.6 into 10 power minus 9 meters. Find the energy of the electron. Now you are asked to find the value of E. So how do we do that? So T is equal to e power minus 2 gamma L. This we know. Now if we take ln on both sides, ln is to the base e and log is to the base 10. Okay. So here it is e power something, so I am taking ln. Okay, natural logarithm. Minus 2 gamma L. So we know that ln e to the power m and e would be m ln e to the base e, and we know ln e to the base e is equal to 1. So this would be m into 1, which would be m. Okay. So this would be ln t into minus 2 gamma L ln e to the base e. So this would become 1. So we have only minus 2 gamma L. So the value of E, the E lies in this gamma. So I'll expand this gamma here. Or we'll do one thing, we'll expand it later. First what we do is, we'll keep this gamma on the left side and take this minus 2L to the, we'll keep this gamma on one side and take this minus 2L on this side. Okay. So what will we have? ln t by 2L, right? So now I'll expand this term. So gamma is 2m v minus e by h cross, which is equal to minus ln t by 2l. So when we square on both sides, we get e here, right? E is under the root. Now I want to remove the root, so I'll square this equation on both sides. So this becomes v2m v minus e over h cross is equal to When I square it on this side, it would be minus ln(t) by 2l whole square. Here we are squaring this entire term, so the h cross in the denominator becomes h cross square. Okay. So now what I do is 2m into v minus e. I will take this, let me rub it here. I'll take this 2m over h cross square on this side, okay, on right side. It would become, so this h cross square will go to the numerator and 2m will go to the denominator. So it would become 2h cross square over 2m minus ln(t) by 2l whole square. Now I'll take this h cross square into this bracket, so it would become v minus e is equal to 1 over 2m, so minus h cross ln(t) by 2l whole square, right? I can write it like this. So we want e, so I'll take this e to the right side and bring this entire term on the left side. So that would be v minus 1 by 2m into minus h cross ln(t) over 2l whole square. Okay. So when you plug in all the values, then you will get the value of e. Okay. So here t is 0.8. Let me rub these things. I hope you have noted it down. So I had already solved for this. Okay, we'll do one thing. I'm not going to solve it on board. You plug in these values and try to find the value of e. Okay, I'll give the value of e on the screen, or I'll write it here. It would be somewhere nearly equal to 1 into 10 power minus 18 joules. Okay, but before you solve for this, remember that you have to take the parameters in SI units. Okay, first you need to convert this into joules, this into meter, and use those values. Okay, because here you were asked to find the energy of electron in joules. Okay, so this would be 10 power minus 18 joules. It would be 1 point something, but even if you get 1, that's fine. Okay, but it is in the order of 10 power minus 18 joules. Okay. If you don't get the answer, we'll solve it in the next class. Thank you so much. See you in the next class.